Power steering. A power steering is a mechanical device equipped on a motor vehicle that helps drivers steer the vehicle by augmenting steering effort needed to turn the steering wheel, making it easier for the vehicle to turn or maneuver at lower speeds. Hydraulic or electric actuators add controlled energy to the steering mechanism, so the driver can provide less effort to turn the steered wheels when driving at typical speeds, and reduce considerably the physical effort necessary to turn the wheels when a vehicle is stopped or moving slowly. Power steering can also be engineered to provide some artificial feedback of forces acting on the steered wheels. Hydraulic power steering systems for cars augment steering effort via an actuator, a hydraulic cylinder that is part of a servo system. These systems have a direct mechanical connection between the steering wheel and the linkage that steers the wheels. This means that power steering system failure to augment effort still permits the vehicle to be steered using manual effort alone. Electric power steering systems use electric motors to provide the assistance instead of hydraulic systems. As with hydraulic types, power to the actuator motor, in this case, is controlled by the rest of the power steering system. Other power steering systems, such as those in the largest off-road construction vehicles, have no direct mechanical connection to the steering linkage. They require electrical power. Systems of this kind, with no mechanical connection, are sometimes called drive-by-wire or steer-by-wire, by analogy with aviation's fly-by-wire. In this context, wire refers to electrical cables that carry power and data, not thin wire rope. Some construction vehicles have a two-part frame with a rugged hinge in the middle. This hinge allows the front and rear axles to become non-parallel to steer the vehicle. Opposing hydraulic cylinders move the halves of the frame relative to each other to steer. History. The first power steering system on a vehicle was apparently installed in 1876 by a man with the surname of Fitz, but little else is known about him. The next power steering system was put on a Columbia 5-ton truck in 1903, where a separate electric motor was used to assist the driver in turning the front wheels. Robert E. Twyford, a resident of Pittsburgh, Pennsylvania, included a mechanical power steering mechanism as part of his patent U.S. Patent 646,477 issued on April 3, 1900 for the first four-wheel drive system. Francis W. Davis, an engineer of the truck division of Pierce Arrow, began exploring how steering could be made easier, and in 1926 invented and demonstrated the first practical power steering system. Davis moved to General Motors and refined the hydraulic-assisted power steering system, but the automaker calculated it would be too expensive to produce. Davis then signed up with Bendix, a parts manufacturer for automakers. Military needs during World War II for easier steering on heavy vehicles boosted the need for power assistance on armored cars and tank recovery vehicles for the British and American armies. Chrysler Corporation introduced the first commercially available passenger car power steering system on the 1951 Chrysler Imperial under the name HydroGuide. The Chrysler system was based on some of Davis' expired patents. General Motors introduced the 1952 Cadillac with a power steering system using the work Davis had done for the company almost 20 years earlier. Charles F. Hammond from Detroit filed several patents for improvements of power steering with the Canadian Intellectual Property Office in 1958. Starting in the mid-1950s, American manufacturers offered the technology as optional or standard equipment, while it is widely offered internationally on modern vehicles, owing to the trends toward front-wheel drive, greater vehicle mass, reduced assembly line production costs, and wider tires, which all increase the required steering effort. Heavier vehicles, as are common in some countries, would be extremely difficult to maneuver at low speeds, while vehicles of lighter weight may not need power-assisted steering at all. A study in 1999 on the perceptual fidelity of steering force feedback found that ordinary real-world truck and car drivers naturally expect an increase in feedback torque as speed increases, and for this reason early forms of power steering, which lacked such effect, were met with disapproval. Hydraulic systems. Hydraulic power steering systems work by using a hydraulic system to multiply force applied to the steering wheel inputs to the vehicle's steered, usually front road wheels. The hydraulic pressure typically comes from a gerotor or rotary vane pump driven by the vehicle's engine. A double-acting hydraulic cylinder applies a force to the steering gear, which in turn steers the road wheels. The steering wheel operates valves to control flow to the cylinder. The more torque the driver applies to the steering wheel and column, the more fluid the valves allow through to the cylinder, and so the more force is applied to steer the wheels. One design for measuring the torque applied to the steering wheel has a torque sensor or torsion bar at the lower end of the steering column. As the steering wheel rotates, so does the steering column, as well as the upper end of the torsion bar. Since the torsion bar is relatively thin and flexible, and the bottom end usually resists being rotated, the bar will twist by an amount proportional to the applied torque. The difference in position between the opposite ends of the torsion bar controls a valve. The valve allows fluid to flow to the cylinder, which provides steering assistance. The greater the twist of the torsion bar, the greater the force. Since the hydraulic pumps are positive displacement type, the flow rate they deliver is directly proportional to the speed of the engine. This means that at high engine speeds the steering would naturally operate faster than at low engine speeds. Because this would be undesirable, a restricting orifice and flow control valve direct some of the pump's output back to the hydraulic reservoir at high engine speeds. A pressure relief valve prevents a dangerous buildup of pressure when the hydraulic cylinder's piston reaches the end of its stroke. The steering booster is arranged so that should the booster fail, the steering will continue to work although the wheel will feel heavier. Loss of power steering can significantly affect the handling of a vehicle. Each vehicle owner's manual gives instructions for inspection of fluid levels and regular maintenance of the power steering system. The working liquid, also called hydraulic fluid or oil, is the medium by which pressure is transmitted. Common working liquids are based on mineral oil. Some modern systems also include an electronic control valve to reduce the hydraulic supply pressure as the vehicle's speed increases. This is variable assist power steering. Ferravi variable assist power steering. Ferravi innovated the now common benefit of speed-sensitive steering. In this power steering system, the force steering the wheels comes from the car's high-pressure hydraulic system and is always the same no matter what the road speed is. Turning the steering wheel moves the wheels simultaneously to a corresponding angle via a hydraulic cylinder. In order to give some artificial steering feel, there is a separate hydraulically operated system that tries to turn the steering wheel back to center position. The amount of pressure applied is proportional to road speed, so that at low speeds the steering is very light, and at high speeds it is very difficult to move more than a small amount off center. It was invented by Citroën of France. As long as there is pressure in the car's hydraulic system, there is no mechanical connection between the steering wheel and the road wheels. This system was first introduced in the Citroën SM in 1970 and was known as Vari Power in the UK and Speed Feel in the US. Electro-hydraulic systems. Electro-hydraulic power steering systems, sometimes abbreviated APES, and also sometimes called hybrid systems, use the same hydraulic assist technology as standard systems, but the hydraulic pressure comes from a pump driven by an electric motor instead of a drive belt at the engine. In 1965, Ford experimented with a fleet of wrist-twist instant steering-equipped Mercury Park lanes that replaced the conventional large steering wheel with two 5-inch 127 mm rings, a fast 15, 1-gear ratio, and an electric hydraulic pump in case the engine stalled. In 1988, the Subaru X6 was fitted with a unique hybrid adaptive electro-hydraulic steering system that changed the level of assistance based on the vehicle's speed. In 1990, Toyota introduced its second-generation MR2 with electro-hydraulic power steering. This avoided running hydraulic lines from the engine, which was behind the driver, in the MR2 up to the steering rack. In 1994, Volkswagen produced the Golf MK3 Ecomatic. This meant that the power steering would still operate while the engine was stopped by the computer to save fuel. Electro-hydraulic systems can be found in some cars by Ford, Volkswagen, Audi, Peugeot, Citroën, Seat, Skoda, Suzuki, Opel, Mini, Toyota, Honda, and Mazda. Electric systems is electric power steering (EPS) or motor-driven power steering (DPS) uses an electric motor rather than hydraulic system to assist the driver of a vehicle. Sensors detect the position and torque of the steering column, and a computer module applies assistive torque via the motor, which connects to either the steering gear or steering column. This allows varying amounts of assistance to be applied depending on driving conditions. Engineers can therefore tailor steering gear response to variable rate and variable damping suspension systems, optimizing ride, handling, and steering for each vehicle. On Fiat Group cars, the amount of assistance can be regulated using a button named City that switches between two different assist curves, while most other EPS systems have variable assist. These give more assistance as the vehicle slows down and less at faster speeds. A mechanical linkage between the steering wheel and the steering gear is retained in EPS. In the event of component failure or power failure that causes a failure to provide assistance, the mechanical linkage serves as a backup. If EPS fails, the driver encounters a situation where heavy effort is required to steer. This heavy effort is similar to that of an inoperative hydraulic steering assist system. Depending on the driving situation, driving skill and strength of the driver, steering assist loss may or may not lead to a crash, 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 to a crash. The difficulty of steering with inoperative power steering is compounded by the choice of steering ratios in assisted steering gears vs. fully manual. The NHTSA has assisted car manufacturers with recalling EPS systems prone to failure. Electric systems have an advantage in fuel efficiency because there is no belt-driven hydraulic pump constantly running, whether assistance is required or not, and this is a major reason for their introduction. Another major advantage is the elimination of a belt-driven engine accessory and several high-pressure hydraulic hoses between the hydraulic pump mounted on the engine and the steering gear mounted on the chassis. This greatly simplifies manufacturing and maintenance. By incorporating electronic stability control, electric power steering systems can instantly vary torque assist levels to aid the driver in corrective maneuvers. In 1986, NSK put the EPS for battery fork into practical use. In the subsequent 8 years, Koyo Seiko Current JTEC, NSK developed a column system exclusively for minicars, sold only in Japan, such as Suzuki and Mitsubishi Motors. However, this simple method was noticeable due to the inertia feeling of the motor at the time of rapid steering for danger avoidance in low-speed running, at the time of high-speed running at which the steering force became small, returning to the manual steering. As a result, that system was not adopted. In the late 1990s, a direct full control system of a rack assist without clutch to a regular car was put into practical use in the Honda NSX, initially automatic only. Since then, there has been a transition from a brush-attached motor to a brushless motor in the rack type of ordinary vehicles, and this method has become mainstream. Electric power steering systems appeared on the Honda NSX in 1990, the MG-F, the Fiat Punto MK2 in 1999, the Honda S2000 in 1999, Toyota Prius in 2000, the BMW Z4 in 2002, and the Mazda RX-8 in 2003. The first electric power steering system appeared on the Suzuki Servo in 1988. The system has been used by various automobile manufacturers and most commonly applied for smaller cars to reduce fuel consumption and manufacturing costs. Electrically variable gear ratio systems. In 2000, the Honda's 2000 Type V featured the first electric power variable gear ratio steering VGS system. In 2002, Toyota introduced the variable gear ratio steering VGRS system on the Lexus LX 470 and Land Cruiser Cygnus, and also incorporated the electronic stability control system to alter steering gear ratios and steering assist levels. In 2003, BMW introduced active steering system on the 5 Series. This system should not be confused with variable assist power steering, which varies steering assist torque, not steering ratios, nor with systems where the gear ratio is only varied as a function of steering angle. These last are more accurately called nonlinear types, e.g. direct steer offered by Mercedes-Benz. A plot of steering wheel position versus axle steering angle is progressively curved and symmetrical.